Hello, my name is Yanis Dizoglu. In this video tutorial, I'm going to discuss principles of software design. By the end of this video tutorial, you will be able to have a clear understanding of the principle of software design. The first thing we need to talk about is procedures. In fact, I'll put the procedures first. So I'm just going to right click here, insert a new row above. Okay, that's better. And I'm just going to let's remove these extra spaces then. That's better. Okay, so I'm just going to put procedures first. And then I'm going to talk about variables. And then I'm going to talk about functions. And you will find out why I've put this order here. So when you're actually developing a software application, think of a container. So a procedure is a single line of code. In fact, the variable will come above. Yeah. Okay. So let's talk about variables. A variable is a container. Let's put a container. It's only a little container. Oops. Let's go there. Is that because okay, that's better. Okay. Think of a variable as a container, little container, which basically contains the word hi. Okay. Or the score. Okay. So 22. Let's say it's the score. So a single value. Now, the single value could be first name and surname. It doesn't have to be a single word or a single number. So it could be Ioannis Dizoglu. So this is a variable. So a variable is a container which contains specific information. Now, a procedure is a bigger box, slightly bigger box container. Okay, so a procedure is a bigger container. Let's put this there. That's a variable. The first one is variable. The second one is a procedure. Now, a procedure can contain multiple variables. Let me go to the code and I'll show you exactly what I mean. So here, I'm just going to go to Toolbox. I'll just create it. Let's start again. Just going to create a new project. It's going to be Windows Phone application. I'm using the C# language, desktop application, and Windows. I'm not gonna name it appropriately. It's only a sample here. So I'm just gonna show the toolbox here. Let's pin it here so we can have it all the time. I don't really need the debugger at the moment, so let's close that. So let's put a button. When somebody clicks on this button, let's put a clear name here. What is my name? And I'm just going to name this button appropriately. So I'm just going to put BTN for button, and I will say name. Enter. As you notice, I capitalize every word after the first word is capital letter, begins with a capital letter. This is easier for me to understand, and this is the common name conversion. So I'm going to double click this button now. And the first thing I need to do is create a variable. So I'm going to call this variable string. It's going to be a string data type, and it's going to be name. And I will say is equals to, and then in double quotes, I'm going to put Ioannis Dizoglu, and then semicolon to add my statement. As you can see here, Ioannis Dizoglu contains quite a lot of characters. I want to use a variable which basically I will only keep repeating 4 characters instead of all these characters. So now I'm going to write a procedure. Okay, so this is a variable, and I'm just going to create a procedure. I will say messagebox.show, and then within brackets I will say let's put double quotes, my name is, And then I will say plus after the double quotes. I'm going to point to the variable, which is name. And then semicolon to end my statement. So this is a variable. A variable contains specific information, and this is a procedure. A procedure is a line of code which will execute, and it will basically do something. The computer will do something. In this case, the computer will show me a message box. So we'll press start. So if I click on this button, I have this message box appearing and says my name is, and then displays the variable name. Okay. So by actually creating a variable, let's put here another object. Let's put label, and the default label text will say name. I'm just going to put your name is question mark. I'm just going to put for the name, I'm just going to put LBL name. Okay. So I'm going to double click this button. Now I'm going to add another procedure here. I will say LBL name, okay, name dot text equals to, and I will say name, semicolon to end my statement. So the LB, once somebody clicks on this button, something will happen. What will happen? A message box will show. That's the first thing will happen. Okay, the message box will show a static text and then a variable text. Then, once I close the dialog box, it's going to move on to the second procedure. So the second procedure is going to basically change the text within the LBL name to be the actual text within the variable. And I've got this. So this is a procedure. This is a procedure. And this is a variable. Now, a variable can contain specific information. A procedure can contain multiple information, multiple tasks, like here. So this task is only one task here. I could change the text color, etc., within the same procedure here, but I'm just going to leave this as it is. Now, this container is smaller. This container is bigger because it contains multiple things. Okay, and this container is a function. So this function basically is triggered by actually the button. But I will create a proper function because this is not classed as a proper function. I will create a proper function in a second. But let's have a better understanding of what procedures are. So if I press play now if I click on what is your name, my message box shows, but this procedure is not executed yet because the first procedure I'm having is the message box show. Once I click OK, then it's going to read the next procedure. And the next procedure is going to display the variable name. And that's what I've got here. So that's the difference between variables and procedures. Let's go back to the Word document. Like I said before, a variable is a smaller container, contains specific information. A procedure can contain multiple tasks, multiple actions. An action, not multiple action, an action. So a procedure can contain an action, okay? But this action can contain multiple variables, and that's why the container needs to be a bit bigger, okay? Now we're moving on to function. Now a function can contain multiple variables, multiple procedures, so therefore the container is a lot bigger. So that's a function. That's a procedure. And that's a variable. Let's create a function. And let's see the purpose of creating functions. So if I would like to basically have multiple buttons, let's stop the project. If I would like to have multiple buttons or the same button but throughout the project, I'm just going to create this local at the moment. I'm going to call this button show, and the name will be btn show. And I'm just going to add another button. I'm going to call this button hide. And the name will be btn hide. Let's change the text value to hide. Okay. Let's change the height a little bit. Oh, that's better. Okay. So if I double click this button, I would like to call a particular function. So the function will basically have multiple actions. Okay. So a procedure can contain a single action. A function can contain multiple actions. Like in a video game, a function will contain the character elevating, as well as the woo sound, as well as the you know, something else when the player try to jump. So if you press the spacebar, quite a few procedures are executed. You don't want to keep executing the same procedures, these multiple procedures all the time. So manually. So what you do, you're adding all these procedures within a function called jump. So every time you call the jump function, basically all these procedures are executed. This way you keep the code clean and a lot more effective. So if we go here, I'm going to create a function here, and I'm going to call this function, let's say public. It's going to be a public function. I'm going to call it show. Okay. My btn show, or whatever you want to call it. And so that's, it's going to be void. Sorry about that. So public void. That's better. And it's going to show the buttons. So the first button I've got here is, let's put some more buttons there. Let's say you had options of buttons here. Now let's see, this is button 1. Let's go to the name. Button 3, button 2, and button 1. Okay, I'm not going to change the names. Okay, so by clicking this button, I want to call a function. So the function will hide these buttons. So will show these buttons. Sorry. So I'm going to say button 1 dot show, button 2 dot show, button 3 dot show, okay, and here btn show, instead of actually keep repeating all these procedures here, what I will do is basically call this function. So my btn show, and I will, because it's a function, I will put capital M here, capital B, and capital S to keep to the name convention, because a function always starts with a capital letter. So I'm going to copy this. I can actually go there. In fact, I'm not going to copy it, so you can actually see it. So I will say my btn, as you can see here, the function is already coming up because Visual Studio recognizes that it's a function and it realizes that I'm trying to call a function. So my btn function, enter, open, close curly bracket, sorry, open, close parentheses, and then semicolon to end my statement. That's the only thing I need to do to call the function. So I create the function there, and here, when somebody click on this button, I'm calling this function. Like I was explained before, a jump function contains multiple procedures. I don't want to keep basically having these multiple procedures called all the time throughout the video game. So it uses a function is used as references. So you say, this is what I want to call, and the computer go and fetches everything you want to call based on this particular function. And that's the reason why I said this is a container. So what I'm going to do now, I'm just going to create another function, and this function will basically hide these buttons. And I'm just going to copy the word hide and replace the show basically to hide. And that's why it is important for us to understand functions. You can see how easily it is to actually copy and paste the functions and very quickly and very easily basically call this function. I'm just going to double click on the hide and then I'm going to call this my btn hide. Open, close parentheses, semicolon to end my statement. So now if I press the start button, if I click on the hide, I'm calling the hide function. If I click on the show, I'm calling the show function. So basically, multiple things are happening immediately because the only thing I'm doing here, I'm calling the function. Now I could actually make it private as well, private void, because it is within the same, it is within the same form, private void. Okay, and this will be absolutely fine because I'm not going to use this function anywhere else, so I can leave it as private. But if I want to use this publicly throughout the software application, then I call it public. So if I would test that, again, this works fine because private means within the same form. Okay, so as long as it's within the same form, private void will be absolutely fine. But if you try to create a function that basically goes across your full software application, you change the private to public. Now let's go back to our Word document. Let's just have a look here at the containers. Hopefully things will start making sense. So that's the principles of software design. So we have to have the variables in order to generate the procedures. We can generate procedures without variables, but having the variables there, we're making things a lot more neat, a lot more tidy, because we're putting boxes within boxes within boxes. And as a result, we make things a bit more neat. Now, the biggest box you can actually get in programming is a class. And this is the next thing here. Okay, but before the class we have an object. Now an object is a box on its own. An object is slightly bigger than a function, but smaller than a class. Like I said before, the whole idea is to keep things nice and neat. So a variable can contain specific information. A procedure can contain multiple variables. A function can contain multiple procedures, which multiple procedures can contain multiple variables. An object can contain multiple functions, which contains a function could contain multiple procedures, and multiple procedures can have and a procedure can have multiple variables. Okay, and the next thing is a class. Okay, so a class basically can contain multiple objects, and an object can contain multiple functions, and function can contain multiple procedures, a procedure can contain multiple variables. And the biggest container you can get in programming is a class. So what is a class in real example? I have here a Windows Phone. This is a class. A class contains multiple objects, like these buttons. And each button could contain multiple procedures. And one procedure, and one procedure can contain multiple variables. Integer in 3, 2, 1, go. So let's create an integer. The data type is integer. I will say 42. In fact, I'm 43. And I will say, integer age equals, I will say 43, semicolon, that's my statement. My name is, I will say plus my and I, let's put here space, and I am space plus the variable age. Okay, that will do. I'm not gonna put years old, okay, because this makes me old. So a procedure can contain multiple variables. So if I press start, click here, my name is Anius Zoglio and I'm, that doesn't make sense, let's remove the and I'm 43 years old. I think you get the message here. Okay. So let's go back here. So a class, that's a class. If Windows Phone is a class. As you can see here is the class. It's called Phone1. Okay. Now a class can contain multiple objects. An object can contain multiple procedures. A procedure could contain multiple variables. And a variable can contain multiple words. I forgot the function here. So a class is the biggest container. A class can contain multiple objects. An object can contain multiple functions. So I could put here the same function here. Yeah, I could put loads of different functions here to keep my code nice and clean. So I can generate the functions there and then basically call the function. So my code is nice and clean. So obviously that one will confuse the software. It's not going to know how to show and hide. So just commented this out. So a function, an object like this button can contain multiple functions. A function can contain multiple procedures. A procedure can contain multiple variables, and a variable could contain multiple words. And that's the containers. So I think I'm not going to bore you anymore. I'm pretty sure you understand that. So that's the containers. And by actually using this kind of containers, we're not really using containers. It's just an example. It's metaphorically speaking here. We're making the code look nice and clean. The next thing we're going to talk about is the predefined code. Throughout my explanation here, when I will start typing stuff, you could actually see the suggestions here. Messagebox.show. So this is a predefined code there, okay? Now, a predefined code is added in order to speed up the development process. For example, if I add a new button here and I double click on this button, here is a predefined code. I don't have to actually type anything. By double clicking, this code is added automatically for me. So it's picking up straight away, knows that this button is called button 4. And it has the click event. So by actually having and using predefined code, we speeding up the development process quite a lot. Because in the industry, time equals money. And we don't want to waste time. Because we waste time, we're wasting money. And now we are going to talk about abstraction of data, inheritance, and encapsulation. Now, the inheritance is, I'm just going to show you Chrome. Okay, so Chrome uses inheritance. Okay, and you could actually do this in your software application as well. How does it use inheritance? So I've got a Windows, I've got my class, my original class, which is called Google Chrome. And here I've got a tab within my class. I've got a tab which basically shows me the default web page here. Okay, so if I go to the plus icon, I'm replicating the exact same tab here as many times as I want. And this is what it calls inheritance. Inheritance is when somebody dies, you inherit some money. So it's passing on to you. So basically something that is already exists passed on exactly the way it was originally. Okay, that's inheritance. So when we actually developing software application, it is important for us to actually apply inheritance in our software application to ensure that the software application is kept quite small in file size. Prior to this inheritance functionality, okay, software applications need to open multiple times. So I had a Google Chrome window here. So then I had to actually start a new process of Google Chrome. And then I needed to start another process of Google Chrome. And every single time I start in a Google Chrome process, I'm using more resources than need to. So if I close these windows, I can still do my work with the actual single window. By using inheritance, I'm keeping the software smaller. So that's what inheritance is. So if I highlight all this, right click and select send to zip folder. Yes. So I have encapsulated all these files and folders within a single location here. That's what encapsulation means. So by encapsulating code, we're ensuring that the code can be actually transferred easily and accurately from one location to another. So when you're actually generating projects, your projects are not all over the show. Your projects are within your project folder. So if I close this window, yes. Now what I'm about to do, I have now encapsulated the software. I'm just going to double click on setup and basically go through the installation process. So this is what encapsulation means. Inheritance means once I have encapsulated this, let's put it into a zip folder. I could actually email this to other people, and other people will be able to basically unzip the software and then download and install the software. So that's what abstraction of data is, inheritance and encapsulation. Now, an input is basically when we actually go through the software application, you can generate an input and you can generate an output. So the input is when somebody clicks on this button. So that's the input. The output is basically the message box. So the input could be a click of a button or a mouse move or I could actually add different events. For example, I could click on my form. I can click on this little lighting event, and I will say on form, on mouse, let's say on drag, active, that's the keys. Let's go to mouse. Okay, mouse event. So on mouse move. Okay, so mouse move, I'm just going to double click here. So on mouse move, I'm just going to call this function. Okay, this function actually, to hide the buttons. Okay, so if I press start, okay, okay, if I move my mouse cursor, okay, the buttons disappear. I can click here to show the buttons. Now if I move away, as you can see, as soon as I move my mouse cursor into this gray area, that then basically triggers the function. So let's go back here. So that's the input. That's the output. So the input is what I'm doing with my mouse or my keyboard. The output is what the outcome will be. The procedures basically are executed, and what will be the output? A message box or hidden stuff or a sound or a particular object within the software elevated, like a jump function where the character actually raised up. Okay. Now, processing is something that happens in between the input and the output. And in order to actually display processing in the real world, we are adding a loader. A loader enables us to actually see the processing. The loader is basically go back and forth based on the input and the output, input and output, input and output, to basically to keep checking if the loading time is equals to 100%. If the loading time is equals to 100%, then the action, the procedure is executed. While the loader is still not 100%, there will be a loop there that is keep repeating over and over again until the loader reaches to 100%. So the processing is something that goes in between input and output and basically enables us to see the process. Finally, determination of scope. What is determination of scope? Determination of scope is basically what we need to do in order to meet the client's requirements. So the determination of scope is how many variables we are going to use, how many functions we are going to use, which language we are going to use. Are we going to use OOP, EDP, or procedural programming? Are we going to be using Python? We're going to use C#, C++. We're going to use Java. We're going to use functions or variables. We are going to add quite a lot of comments. Determination of scope is also within the determination of scope is you have to identify how many developers you will need as well for this particular software application, how long it will take you to complete the project, and all this based on the determination of scope. So that's what determination of scope means. It's basically the original planning in order to develop a particular software application. That's what the determination of scope is. Hope you've learned something new today. I hope you will use these new skills. Thank you very much for watching. Bye.